Okay, welcome everyone to the May Lunch and Learn series for the Air and Waste Management Association, the Rocky Mountain States section. So I'm Anarelli Morales. I'm the secretary of the board of directors, and I am the air quality policy analyst for Weld County. And I'm super excited today to introduce Ellison Carter. She will be our speaker for today. And Ellison is, let me get my information. She is a professor at CSU. She's an associate professor in the Department of Civil and Environmental Engineering at Colorado State University. Her research focuses on indoor air quality, housing and health, air pollution exposure assessment, and the design and evaluation of environmental interventions. Her work integrates engineering measurements with community engaged approaches to improve indoor environmental quality, particularly in underserved housing. And today she'll be talking about air indoors. So take it away, Ellison.
All right, thank you, Anarelli. I'm happy to be here. I do not have people's headshots or videos up, so I am speaking somewhat to a black box, and I'll try to maybe get some help from Anarelli if people have questions or comments as we go along.
Yes.
I'm happy to be here, and I did glance at a few of the participants. Some I know very well. Former student whose work will be represented here is in the audience, and actually a few people who I think we've interacted with conducting our indoor air quality and ventilation assessment program in collaboration with CDPHE. We've done some stakeholder interviews, and I believe I saw a few names of people that we've actually conducted interviews with. So I want to just extend a thanks to them for participating in our one of our studies, and also glad for you to be here. In reflecting on what to talk about, I think there's sort of a traditional arc to talks like this, where we present a study design, what motivated it, what measurements we did, and what we learned. And there'll be some of that here, but because I'm generally in the spring teaching undergraduate students who are looking for jobs, some of them are environmental engineers looking for work in air quality, some maybe not as interested in air quality. I've been sort of confronted with thinking about what it means to develop engineering expertise in an era of powerful AI. So some of the thoughts that I want to present are thinking about what we've learned from our studies that maybe doesn't fall into sort of the traditional arc of presentation in a paper or a seminar. And hopefully that might be grounds for some interesting conversations or questions, which I hope I leave plenty of time for at the end. So for those of you that might know the author Haruki Murakami, I'm quoting him or paraphrasing him. He wrote a book called What I Talk About When I Talk About Running. It's a reflection on who he is as a writer. And I like the way that he thinks about things, and it sometimes informs my own thinking. So I've titled this What I Talk About When I Talk About Studying Air. Before I get into any of those stories, this is not everyone that I have had the pleasure of interacting with, but it certainly represents a large swath of the students and staff and colleagues and collaborators that I've worked closely with and who have directly informed, in some cases directly conducted the work that I'll be presenting here. A few to call out for the studies that I'll be presenting on. Xiaoying Li in the upper left has been a lead researcher on our home health box work that I'll present about. Colin Bremer, third from the left in the top row, is the now PhD degree holding person who led much of the coal-based or the coal energy transition work that we'll be presenting on. And there are a few others in here that I might mention as we go along. So Act 1, a story about air, 20 years measuring what people breathe. I'm going to highlight a couple of studies that we worked on. The cast of characters that feature in the next two stories are primarily pollutants that I'm expecting would be familiar to many people in the audience. PM 2.5 or fine particulate matter, regulated outdoors for decades now. Also something that we measure indoors and we measure on people to understand what they're exposed to. We also measure VOCs of volatile organic compounds, which can give us some insight into indoor sources and activities that contribute to indoor air pollution and exposures. We also think about temperature, not just comfort, but how it drives chemistry and emissions and controls. Relative humidity, sort of in the same spirit, matters a lot for indoor environments and what is deemed comfortable and how people perceive their air quality indoors. And then two other characters that are worth knowing for today are the air pen and the home health box. These are the names of technologies that I've had the opportunity to collaborate on developing with mechanical engineers here at CSU. The air pen is a wearable personal sampler, so it's a bit smaller than the home health box, which is more of like a shoebox sized plug and play stationary monitor that we use for indoor air quality monitoring. What's motivated some of that technology development is the historical imprint of industrial hygiene. What you see here, some of you in the audience maybe have used some of the devices represented, like a personal PM sampling pump, a thermal desorption pump, a battery pack that might have been worn in the past to carry these devices around. On the right-hand side is a Q-Track that would be used for sensing volatile organic compounds. And then if we want to measure things like light and noise and temperature and relative humidity, we would need additional instruments in the past. And so for the last decade that I've been here at CSU, been able to partner with a few researchers, including John Volkins, Jess Treiner, Casey Quinn, Christian Larange, and others at CSU to work on taking what the measurement capability is of all of this equipment, which is hard for an individual to wear and also difficult to set up in people's homes, and shrink it down to something that's wearable. So the AirPen is a personal exposure device. This is a V1 or version 1. It now looks a little bit different, but it's roughly the same size, and it clips on to say like a shoulder, can be worn as with a lanyard around the neck. It's about 200 grams. It's very quiet, and it can measure PM 2.5 and VOCs, both with real-time sensors and filters and sorbent tubes. So the filter sits at the top, and the sorbent tube is basically in the chamber of the device, which allows us to get both time resolved data and time integrated samples that we can evaluate later in the laboratory. The AirPen in the field has been deployed primarily in occupational settings, although it's now seeing expanded applications in non-occupational settings. Our goal initially was to enable taking 100 samples in a day, and we were able to accomplish that at a workplace that was a manufacturer of wood-based furniture. And we've deployed this AirPen. It's featured on the shoulder, the upper left shoulder of the person in this photograph. We've been able to deploy that in settings where people wear it at work, but then they also wear a different one at home, so we can separate out home-based exposures and work-based exposures. The home health box, the other character that I will be talking about a bit today, is an indoor air quality focused device for measuring indoor air quality at home, or it could be applied in other indoor environments. The study that I'll present on is a home-based study. This sampler has a bit more capability than the AirPen. It has the yellow and green inlets allow for 2 filter-based samples. Those can be different, like PM10 and PM2.5, or they can be 2 PM2.5 samples. We can also do respirable PM and other sort of fractions. And then internally, there are sensors for nitrogen dioxide, carbon dioxide, and VOCs. And then in the lower portion of the box below the green and yellow eyeballs, if you will, is where we can fit up to 2 sorbent tubes for capturing gas samples that we would be using for VOC analysis. It is pre-programmable so that we can ship it out to someone's home and they plug it in and push one button and get it started. If that sounds implausible to you, it did to me too, but we've now conducted a study with over 100 households where we were able to ship the box to them 3 times for 3 separate weeks of measurement, and they would ship it back to us. We'd extract the samples, analyze them, and then ship back another box for sort of the same deployment. In the field, we've deployed this in a number of different places, including Fort Collins, Las Cruces in New Mexico. We've partnered with the city of Las Cruces to do some measurements in homes that they want to understand indoor air quality better. We've deployed across a range of locations in Denver and published a few articles on the use of this device in the field. I'll move on. So 3 separate stories about air pollution and what we've learned. I'm going to start with a story set in Beijing. I have been working in China since 2011, where a fair amount of work has been going on across a range of research groups to understand transitions from use of solid fuels to cleaner cooking fuels and heating fuels. So our particular study was situated in rural Beijing, and starting in the late 2010s, the early 2010s, China's household coal ban was rolling out across a larger range of households. The household use of coal is primarily for heating, and it had been banned in urban settings, so as early as 2008 or a little bit prior, in anticipation of the Olympic Games. Coal use for space heating indoors was banned in the urban core of Beijing, but Beijing is a municipality region that includes actually many rural households, and the ban on coal was rolling out in a staged fashion across that municipality and other parts of northern China. And as millions of rural households are transitioning from coal to gas or electric heating, we wanted to understand whether this policy changes what people breathe. This map is on the upper left is the country of China, and then zooming in the red dot, that's the municipality of Beijing. Beijing, as you know it as a city, is in sort of the lower third of this zoomed in map. And so what we've shaded different colors, Miyun, Huairou, Mentogo, and Fangshan are the names of districts within that municipality region. So in those 4 districts, we recruited 50 villages, and we were able to make measurements over multiple years, spanning from 2018 to 2022, with a pause on in-home measurements during the peak of COVID. Measurements in people's homes and communities included indoor and personal measurements, as well as community-based outdoor measurements. So when I talk about outdoor measurements, they are in a village, and a village may be anywhere from maybe 20 to several hundred households, and so it's typically located in a central location. We also measured indoor temperature and health outcomes and well-being, working with a team of economists and epidemiologists. I'll just be presenting on the air pollution work today. Most of what we did was funded through the Health Effects Institute, which is based in the United States and is a collaboration between motor vehicle associations and EPA to be sort of a third party in terms of gathering evidence on air pollution and health impacts. The main transition was from coal-based heating in your home. So the pictures that show the coal stoves were either stoves in people's homes or directly adjacent to their homes that were used to produce heat that was distributed throughout the home. And the shift was to no longer use coal and instead use primarily electric-driven heat pumps. And in some cases, gas was used in terms of the overall transition, but in terms of what we studied, it was primarily electric heat pumps. So I don't know if I'll be able to get audience engagement on this, but I will pause just to have you sort of think through what you think might happen. So the story, millions of rural Chinese households switched from coal to gas or electric heating between 2018 and 2022, which is our measurement period. It's bookended by other years, earlier and later, and then we measured outdoor, indoor, and personal PM. So outdoor, I explained, is sort of in the community, not very far away, not like the county level monitors that we have here would be far away from you. They're in the villages where people were living. And then indoor measurements in their home, and then personal measurements using devices that they could wear, like the AirPen, but it was a different device actually called the UPass. So 2 questions. What do you think happened to outdoor, indoor, and personal PM? And for those of you in the audience that already know, I guess you know the end of the story. Did it go down? By how much? Did it stay the same? And then for whatever your guesses are for outdoor, indoor, and personal, how confident are you? Not sure at all, somewhat sure, very sure. Give you a few seconds to think about your answers, and I'm looking, I'm not sure I'm able to see anybody commenting in the chat, but
We don't have anyone yet, but
okay,
I,
no
I
problem. I
do.
think I mostly just wanted to give people a chance to think about what do you think would happen? What would PM 2.5 go up or down for any of these 3 measures?
Yeah, I do appreciate including the confidence question.
Yeah.
Because I was very confident with like, yeah, of course, it'll do this, this, and this. But then you question me, like, oh,
Yeah.
well,
Yeah, how confident are you in your guesses? And I'll try to come back to that at the end. So the highest level finding, or a way to summarize our understanding of the PM 2.5 mass metric, was that personal and outdoor PM didn't shift really as much as expected. If we read our report or the papers that have come out of this work, you'll see these figures. They are showing on the x-axis mean change in outdoor at the top and personal filter-based PM 2.5 mass at the bottom over the course of the study. And the orange vertical bar that I've placed overlaid on that figure is meant to help draw your attention to the 0, meaning no change. What you see as the black circles are the difference in difference analyses, both an adjusted and a non-adjusted result. I won't spend a lot of time on those 2 differences right now, but what stands out from these plots is that the circles and their error bars are intersecting with 0. So the way we would interpret this is that outdoor PM and personal PM did not change as a result of the coal ban. However, indoor PM did change. So now if you look at the figure in the middle here, this is our sensor-based seasonal average of PM 2.5. And what you can observe here is that the circles and the error bars are to the left of the orange vertical bar, indicating that we can interpret these results as a change in indoor PM. One really, I would say, one of the most important findings from the work was our ability to do chemical analysis of PM 2.5. And I will say I'm somewhat flexibly calling these coal combustion tracers. We weren't able to separate out coal specifically, as you might with, say, organic analysis, but with the elemental analysis we did of mass on PM filters. So the figure in the middle is showing sort of a few filters that are loaded with PM 2.5, and that mass is one crude metric of exposure, but we can also take the PM 2.5 mass and then analyze it chemically to see components. And I'm just showing an illustrative figure here of what components might be, like salts, soil, aluminum sulfate, black carbon. These, the bars here are not actually the results from our particular study, but just meant to illustrate that we can take that PM 2.5 mass and apportion it to different sources, either elemental components or clusters of elemental components. And when we do that, and then reanalyze the data, not on the basis of PM 2.5 mass in bulk, but rather these components, what I'm showing on the right-hand side is work that Colin led on outdoor PM composition analysis relative to personal exposure composition analysis. And when we look at personal exposure, we can see a change in personal exposure of the components of PM 2.5 mass that would be most associated with coal. And so a way to interpret this is that PM 2.5 mass didn't show us that the coal ban worked, but components of that mass that are associated with coal did. And that level of specificity in our measurements was required to sort of elucidate that result. Our interpretation of these results is primarily that policy doesn't equal exposure. Outdoor air quality improved for lots of reasons outside of just coal ban over that 2018 to 2022 period. And therefore, our understanding of our results is that outdoor air quality really didn't provide a good measure of how the coal ban was working because it was influenced by so many other factors. But chemical composition and not just mass concentration, in this case, the measurements really mattered for revealing the more subtle story around the coal ban and its impact on personal exposure and indoor air quality. Okay, so I'm going to move on to next story. I'm kind of trying to watch time here. We're still interested in how interventions influence people's experience in their homes, including their air pollution exposure. And in the case of home-based air quality, a lot of times people don't have much insight on what their indoor air quality is. Increasingly, people have greater access to information about outdoor air quality, but that, for I think somewhat obvious reasons, it doesn't extend indoors. Indoor air quality for most people is invisible. There are some, some examples where people can sense through, the draftiness or the stuffiness of a space or odors. Those can be associated with worse indoor air quality, but they're not perfect proxies for indoor air quality, where much of what might be in the air isn't very possible to sense through vision or sense of smell. So our underlying question for the next study I'm going to talk about is what happens when you give residents individualized, easy to understand feedback on their in-home air quality. And I'll say we did start up front with the premise that we believed our information to be easy to understand because we had trialed it in a phase 1 SBIR NIH-funded grant and gotten feedback that it was relatively easy to understand. And yet, in new populations, we continue to deploy surveys to ask people about their impressions of the information and how we delivered it related to their indoor air quality. So I'll walk through some of that study design. So the study's design is a randomized control trial. It's now closed. We ended up recruiting about 100 households. 44 were treated households and 49 were control households. 3 repeated deployments per household, where, like I described earlier, the home health box was shipped to someone's home. They plugged it in. It ran for a week. They shipped it back to us. We extracted samples and data, produced a report that I'll describe in a bit more detail, sent them the report if they were in the treated group, and did not send them anything if they were in the control group. And then after a few weeks, sent them another box, repeated that process. So households that were in the treated group received a report 3 times after each deployment of the 3 deployments. Households that were in the control group had 3 deployments of the box, the home health box, to collect the indoor air quality data, but they didn't receive a report explaining what was measured until the end of the study, and then their report included all 3 measurement deployments. The treatment was a personalized home health report that had features that were unifying across all the reports to sort of homogenize the treatment, but then also had personalized elements that were based on survey-based information we gathered about their household. So a good example might be something like we would ask about the type of cooking devices that they had and used. So if they had a gas stove and they used a gas stove, we would take that into account when interpreting their nitrogen dioxide measurements that we were reporting to them. So now I'm going to walk through what that report really looked like. It had 4 pages. It was always delivered electronically. And the first page was always the same, other than telling them if this was their first, second, or third report. The second page was also always the same. It was how to read the home health report. We had color-coded by green, yellow, red for low, medium, and high concern. We explained the pollutants that we were reporting on, which were fine particulate matter, PM 2.5, nitrogen dioxide, and carbon dioxide. And we primarily provided them with information about what indoor sources were common and what common health effects are associated with those exposures. The third page was their data for them for the week of measurement that we had collected. And the dial plots that you see here show the concentration of PM 2.5, nitrogen dioxide, or CO2, time averaged over the week-long measurement period. On the right-hand side, it's very small, but those are the time series data that were for those same three pollutants. In this case, they're all green because they all stayed below what our best available health guidance levels were. I'd be happy to field questions about how we made decisions about those exposure tiers. Indoor environments are not governed in the same way that outdoor environments are. So it is a mixture of EPA, outdoor standards, indoor guidance, like from professional societies like ASHRAE for CO2 that we applied to the data. And that's what's explained in the second page of how to read the home health report. And then finally, on the fourth page were actionable recommendations that we could make based on their data. The language and iconography that we used was the same across the reports, but we had a bank of about 40 to 50 unique recommendations that were generated by our team based on what we learned from survey-based questions about activities and what their home was like, as well as what their data revealed. So we had, for this particular home where mostly the concentrations were quite low, we have an overall recommendation that overall the indoor air quality is good, keep up the habits for healthy indoor air. We also provided specific guidance for things like HEPA filter, vacuuming, inspections for HVAC, and our recommendations ranged from zero cost, something like opening a door or window, to higher costs like soliciting or contracting an HVAC inspector. So same sort of pause here, just to give yourself a chance to engage with the content. So we had 100 households with 3 deployments of plug-and-play air quality monitors. Half received personalized feedback after each deployment, half did not. They did at the end. And so 3 questions to sort of reflect on before I present the results. Did personalized feedback change air in people's homes? Yes, clearly, somewhat, not really. Depending on who you are in the audience, you might fall into different camps here. Second question, did it change how people felt about their air? Maybe some of you have also engaged with people in terms of their perception of air quality. So this is a separate question. And then how confident are you in both those answers? Are you not at all sure, just guessing in the dark, somewhat sure, or very sure? Give you a couple seconds to think about what your own thoughts are. Again, I'm just keeping an eye on time too. We have a full hour, right, Anne, really?
Correct.
Okay. I think I'm on track then.
Mm-hmm.
All right, and hopefully I've given people a chance to think of what their answers would be.
Somebody in the chat said, my guess is somewhat to both. In my experience, it could be mixed.
Great. Thanks for offering your thoughts. I would say that's fairly on point with what we learned. So I'll walk through our results. Thanks for sharing, and thanks for sharing, Nina. We use mixed effects models, same approach that we use with the Beijing-based Kolban evaluation. And I would say my interpretation of our results is no clear overall reduction from report back alone. So the indoor air quality metrics, which are shown here, PM10, PM2.5, nitrogen dioxide, and carbon dioxide, those are the things we measured and reported on. We did not see a very clear reduction from the report back alone. However, there's some modest indication in that top row, that A row, if you look at nitrogen dioxide and carbon dioxide, those confidence intervals are not crossing the orange vertical bar, which is 0, and suggests that the mean change in concentration for nitrogen dioxide and carbon dioxide showed a modest influence or impact of the report back mechanism. Perhaps to some of you in the audience, not surprisingly, but I think it was very valuable to confirm with the data we collected. We did see heterogeneity in our results. Our subsamples of households that had high baseline levels or gas cooking or smoking or candle burning, these were much smaller subsets of our overall study sample size of 100. And so the results should be interpreted with more caution, but we did see larger effects in those subgroups. So if homes had higher concentrations to begin with, they had a higher margin or potential to reduce. We did see that those homes it did have higher mean change in reduction in particular pollutants. Homes that had gas cooking, nitrogen dioxide is the main source, or sorry, gas stoves are the main source of nitrogen dioxide in people's homes. And we saw that in homes that had gas cooking that were in our treated group, we saw a more measurable or more statistically significant, not really more, we saw a statistically significant reduction in nitrogen dioxide levels. The bottom row here, row B, is just showing mean change in terms of a percentage instead of an absolute mean change in concentration. Also in homes where there was smoking or candle burning, and we knew that from their survey, and then we saw from their data that they had higher concentrations of PM 2.5. In those particular homes, we saw a measurable decrease in PM 2.5 levels. But again, those subsamples, the study was not designed specifically to look at those subsamples, but we having subsets of about 15 to 20 for those subsamples, we did do some additional secondary analyses that showed the impact of the report back on those subgroups. I asked what people thought how people felt about their air might have changed. And so one thing we were really interested in addition to the indoor air quality metrics, was how people experienced having this sort of level of intrusion into their home, and also, how they felt about getting information about their indoor air quality. So we asked them to rate a range of sort of feelings. We had curious, interested, empowered, respected, informed, helpless, worried, and scared. So we tried to span, and we did this in a phase 1 again. So we, working with a team on our survey development, these were some of the range of feelings that we wanted to gauge people's intensity. So the perceived intensity levels range from 0 to 5, where 0 is I don't have that, I'm not curious at all, to 5 being I'm very, very strongly curious. Similarly, like for worried, I'm not at all worried, versus 5, I'm very, very worried. So we asked these questions after each deployment for our treated group, and then we asked these questions of our control group at the end. And on the right-hand side is the figure representing what we found. So those 8 words on the left-hand side are now 2 rows. And the colors indicate perceived intensity level. So our dark green and light green are high intensity, so 5 and 4. In the middle, 2 and 3 are in sort of the pink teal range, and then purples are more in the 0. Gray means no response. And so what our takeaway from these findings is that the proportion of treated participants reporting strongly positive responses increased. Negative emotional responses were fairly uncommon. So when you look at words like helpless, worried, and scared, we see mostly purple, which indicates 0 to maybe up to 1 to 2. And control participants were a bit more likely to report strong feelings of worry or fear. And we felt that was maybe could be interpreted as having less information about what to do while measurements are going on. How we interpret, what this means, we believe that the information reshaped how participants understood their homes. Our ability to see that reflected in the indoor air quality metrics themselves was more subtle, maybe a function of time, maybe a function of the multiple mechanisms that influence those indoor air quality metrics, some of which are outside of their control. And their feedback shaped their experience more than their exposure. I think in the interest of time, I'm going to skip the third story and sort of move to my closing remarks, and then hopefully open the floor for some questions. So you'll have to excuse me while I flip through this. So I would say, reflecting on a range of projects that I've had the fortune to work with great people on, there is what we present in our papers, which again, as I mentioned at the beginning, feels fairly traditional and hasn't changed very much. We motivate a story, we motivate a study through a desire to understand either relationships between air pollution and health, or how interventions work when we try, when they are being implemented in the real world. How do they influence air pollution exposures? And yet there's quite a lot that I think we build as knowledge and expertise within our team and across teams that I've worked with that doesn't really feel owned by a particular discipline. And so that's what's got me thinking lately about what is it to develop expertise, especially in an era where powerful AI is capable of doing much of the analysis at scales and speeds that are pretty unprecedented. And so the cast of characters that I've been thinking quite a bit about under an air pollution frame, but I think extending beyond that, are intuition and taste and expertise in the center here, and then sort of bookended by interdisciplinarity, working across fields, and then judgment. What does it mean to make decisions when we have sort of incomplete or imperfect information? So earlier, when I asked you to make some predictions, I asked, what did you think would happen to PM 2.5 in our Beijing households? What did you think would happen with personalized feedback? I think a lot of richness lives where your prediction emerged. That's your intuition at work, and your intuition is something that you built and developed over time. If there were moments in the presentation where you were sort of affirmed, like, oh yeah, that's definitely what I thought the result would be, or surprised, that wasn't maybe what you thought the outcome would be. Both types of responses, I think, is a dissonance where learning happens. And I'm trying to think about ways to bring that into what I do in terms of teaching. Again, because I think the ability to get answers to questions, or even design research, implement research with the use of AI agents and tools that are emerging quite quickly, I think it's causing me to think about how intuition and the sort of expertise develops, and what do I need to be doing with students to help them develop that expertise. The question about confidence, to me, is one of the more interesting features of this. Is like, just because we have intuition doesn't mean we trust it. So learning, what kinds of intuitive responses or surprise responses are trustworthy versus ones that are maybe an indication of a gap or lack of knowledge or understanding. I think it's difficult to say how intuition develops. Some people that I've been talking to over the last year or so on this topic are quite reluctant to, they almost feel that as an intuition arises, it's an opportunity to sort of relegate it to the side, and others lean in more, and that seems to be a fairly complex process of either noticing one's thoughts or intuitions or judgments, depending on what language you want to use, and then how you choose to act on that information. So when I think about what this sort of means for the kind of work we do, I didn't have a chance to present on the workplaces necessarily, but in terms of the work in Beijing and the work in Colorado that I did present, where I am finding this judgment emerging is in places like how we read or interpret the findings and choosing what outcomes to measure and why. So again, in the audience, I know Colin knows this really well. We work together on making decisions about what we would measure in that PM 2.5 mass. And even if that decision making is replicable in a generative artificial intelligence way, much of it was informed by embodied experience with people in the settings where we were working. And the same goes for designing the interventions for the home health report, in that how that report is developed has been in working with community members and working with stakeholders that are giving us insight into how information would be best received. And that live, more dynamic process is something that I feel is still quite a durable part of what we do. Competencies in these intuitive or judgment-based spaces, again, language around this is more fluid and may not be that familiar, but the vocabularies that are being used by some of the leading institutes like National Science Foundation or the National Academy of Engineers, as well as our American Society of Engineering Education and ABET, our accrediting body, at least in terms of engineering, are using language around judgment, around integrated knowledge, around ethical reasoning, creativity, and adaptive intelligence that I think intersect on some of the intuition, taste, and expertise questions that I'm finding myself asking. So I don't really feel like it's something we train yet directly or assess well. I think it's difficult to do, and it's something I wanted to bring up because I thought this audience might be an interesting one to sort of surface these thoughts that I've been having, given the diversity of backgrounds that I sort of expect are in the room. So I will, I'm just going to move through to the practice space. I think an older paradigm is one in which execution of research was quite scarce, and the bottleneck may often have been analysis, design, reporting. And I think the bottlenecks are shifting towards verification of outputs, deciding what the right questions are, deciding who the right people are to engage and when. And that evaluative scarcity is where I'm sort of shifting my emphasis, at least in terms of teaching. So I'll close with this. I don't know what succeeding looks like in terms of developing or training, early career engineers for the future, but I do think the skills that are hard to name and we don't seem to have a settled vocabulary on, things like tacit interdisciplinary work or discomfort working across fields or intuition and taste, as I've been exploring them. These don't really fit neatly into a particular discipline, but they do feel like an important space to be, thinking about and working on in terms of training. So I think I'll close there. What kind of expertise are we building next? And I'd be happy to take questions or on anything. So.
Awesome. Thank you so much. That was great. So we have 14 minutes left. Can you do a 2 sentence review of or summary of the workplaces story?
Oh, sure. 2 sentence review of the workplaces story. 2 sentences. I can't do two sentences. No, I can try.
The previous
Maybe
slide.
I just won't go to slides. That workplaces thread was a bit more forward leaning. I'll say, again, some people I think on this in the audience maybe have intersected with our team on an indoor air quality and ventilation project that we had a 2-year measurement period for. We went to 50 workplaces in the state of Colorado and measured for 2 weeks indoor air quality and ventilation and gave site level recommendations to site managers or people that we that were our points of contact. And then following on that, we conducted a full-scale analysis of those data We find major drivers of indoor PM to be outdoor PM. We find major drivers of people's experience indoors to be temperature. And so I would say the direction of travel for that work is also informed by others here at CSU and across the state that have been working on heat, sometimes alone as a topic, and sometimes heat and air quality together. Um, I think outdoors, there's been some early indications or maybe ongoing, and I would say newer to me, but that heat advisories and air quality based advisories for outdoor work, the alignment of that messaging may have some additional value than sort of separate messaging, especially if messaging can be in conflict. I would say indoors, it's not quite the same story, and we don't know for sure, but we did interviews with 27 people representing different sort of sectors as stakeholders in indoor air quality management, and thermal comfort came up a lot. And so alignment of interventions that address thermal comfort or that are tuned to thermal comfort might be ways to leverage change in the indoor environment that might also benefit indoor air quality. And that's not new, but that is sort of the brief summary of that work. Thanks, Annabelle.
Awesome. Yeah, I would love to hear more in the future about the messaging component
Mm-hmm.
with outdoor workers and that stuff, because we have the regional air monitoring and messaging group, and I think that that would be something very interesting to them. But back to this. So I do have one question. So for the smoking, or for story two of
Mm-hmm.
in the home analysis, for homes that had smoking,
Mm-hmm.
do you might not have done this, but maybe it could, do you think it could be helpful to partner that data with available public health services or programs? So for example, the tobacco cessation programs,
Mm-hmm.
or even for the cooking stuff, healthy cooking or healthy eating programs.
Yeah, I think I we would love to have a resources page as like a fifth page to that report. Um, because at the time of proposing the work and getting it funded, we didn't have particular partners yet established. And so we really, I would say, um, made our outcomes dependent on the report that we said we would do, and the variability that would arise from providing different resources was too great for us to warrant inclusion in the report. So ultimately, I made the call that we weren't going to include that because it would change the nature of the report and what we were trying to test. And yet, like partners that like we worked with the city of Fort Collins, the city of Las Cruces, we worked with the Center for Lungs and Breathing through the CU Anschutz Medical Campus. So we worked with sort of different partners. Sometimes we're just recruiting at events, so it's not necessarily partner
Mhm.
driven. Um, but in terms of developing resources that could be tied to that report, I think that would be an ideal next step. It just wasn't a very obvious workflow because we didn't always know where people were
Yes.
from before they got into the study. So then once we learned that, I think they could be from quite different places in the state. But ideally, that to me is something that could be um, fairly readily automated, where like knowing their location, if that could pull from existing databases, I don't know what the handoffs specifically look like, but I think we
Yeah.
are often asked, like, what about resources? And then informally in conversations sort of outside of the study design, we can share that information. But I don't even think it has to live in the study design. I just think if the
No.
report is living in the world, that would be a great addition.
I think we would call those referrals. So
Yeah.
once like you make the assessment or health assessment and then you tell them what, like here's what it is, you can make a referral to like the tobacco cessation program, and then they can give them resources.
Yep.
Um, but other questions, please raise your hand or put in the chat. Type in the chat. All right. Everyone's all sleepy, I guess. Okay, here we go. Colin, um, in academia, have you seen any funding shifts or non-financial incentives for including the use of AI in these sorts of studies?
Hmm. That's a great question. I would say relative to 3 years ago, maybe, yeah, 3.5 years ago, the shift that's the most notable is, I would say, a laggard shift of acknowledging that AI is here to stay. I think several years ago when I was introducing it in my classes, I think there was more of a resistance, open resistance. In terms of funding, I think it was just not addressed, like not vocalized at all, even if there was shadow use of AI. Now, I think what is um, more showing up in terms of funding, Colin, is the like bounded funding of like AI for X, AI with X, or doing X with AI. Um, so what I find still to be a um, somewhat of a false line is like there are still calls for funding that have almost no acknowledgement that AI might inform a proposal or inform work. And so I don't think it's resistant to it. It's not an updated RFA. Like the RFA doesn't really acknowledge that the nature of the work itself might be quite different in light of what's available. On the other hand, I think there's now a lot more express calls for funding that state an interest in seeing how AI gets integrated into a proposal. And that seems like only in the last year. Like, yeah, I would say only in the last year ha has that really shifted. Um, has it been meaningful? I think there's sort of two separate tracks here. One is there's a traditional, I would say a more traditionalist approach to like AI and ML being very much related or the same, not quite the same thing, but very close to the same thing. And to a lot of researchers, they're like, we've already been doing that, so we're just going to keep doing more of it. But I think it's a different question to ask about sort of use of AI in workflows that are being done or in research workflows. And that feels like a much more jagged landscape where sometimes it doesn't show up at all, or sometimes it shows up, but in ways that um, don't feel caught up with what's going on in like that space, since it's quite a shifting, or it's a space that's moving pretty quickly. So I don't know if that answers your question, but I tried.
Cool. Well, thank you for the questions. We have 4 minutes, so we could wrap up a little early. I do want to thank you, Dr. Ellison, for joining us. This was super fun. I have so many ideas now. And then I wanted to let everyone else know, to join us next month for our Lunch and Learn on June 10th. It will be Dr. Jonesy Lang on PFAS in waste disposal facilities. So the site is on the chat if you want to go and register for that. And then the recording for this meeting will be up soon, hopefully within a week, on our webpage. And then, yeah, thank you so much for spending your lunch time with us. Thank you. Have a good
Thanks
day.
very much. Yeah, thank you.